Hey everyone, I'm Adam Kelly. Finally back. It's been a little while since the last update, but I have made some progress on the motion blur project and I wanted to share that with you. So what you see here is a trained instance segmentation model that is trained to detect reading glasses, pens, and this reusable drinking straw that I have here. These are just objects I had around my house and that I thought would be good to use for this test because they're not in the original COCO data set that most instance segmentation models are trained on. So I will admit these are not done with 3D rendered synthetic data. These are actually trained using a copy and paste method of creating synthetic data. And if you're not familiar with that method, basically you take foregrounds of some sort of object and you paste them over backgrounds. And you make these fairly realistic, though clearly not entirely realistic images. Obviously, I didn't toss these items in the air and take a picture. They are artificially pasted over top here, but they do look pretty convincing all the same. And they turn out to train neural networks pretty well. So if you're curious how I made this data set, because this is kind of critical to how this whole thing works, I highly encourage you to check out the complete guide to creating COCO datasets course that we have on Immersive Limit. So I created this course a couple years ago, and it has helped a lot of people create datasets for their, for their school projects or work projects. People have used it for all sorts of different things, and it's worked out really well. So if you are interested in that, make sure to check out our courses page on our website, or we'll probably put a link in the description, and use the course referral link too, because on Udemy, that's how we get the most of the revenue from it, and you get a better discount. So anyway, just as a brief explanation of what it does, you take a bunch of photos. And so these are photos I took in a few different places of these objects. So on different backgrounds and things. Now, I don't have that many of these objects here. There's only 50 of them. So the next step is to cut out the object, the foreground. And in this case, with some transparency too. So we're cutting out the glass part too. And I will give full credit to my wife, Kayla, for doing the hard work of cutting these out. It may not seem like it's terribly difficult, and it's maybe not, but just sitting there and doing that tedious work, in my opinion, is very difficult. So thank you to Kayla for doing that work. But basically, you get these, and they have a transparent background. And then you have a directory of backgrounds, and then it will paste them over top. And so the results end up looking like what you just saw. So basically, I have code that does all of this. It pastes foregrounds on the backgrounds, and it also outputs the mask for you automatically. Let me see if I can find those. So because you're pasting that foreground, you can easily create these masks, and then it also converts those masks into COCO format. So you can get the COCO JSON format, which has segmented points and bounding boxes for your data set without you having to actually do it. So that means for all, I think, what is this, 8,000 photos in here, we get free annotation. Without any extra work, which is kind of awesome. So back to this and why I went with that method instead of Blender is because I just wanted to have a baseline. And my thinking was if we could create this data set, train it up, and get it working with no blur, then we would be able to compare it with blur because we can blur those foregrounds, and then we could try it with synthetic data set as well that's 3D rendered in Blender. So that's kind of where I'm at right now. This is using Detectron 2. I was having a lot of trouble getting Matterport mask RCNN working, and then I just could not get Google's TensorFlow object detection library working either. It was really frustrating, and I landed on Detectron 2, which did take a little bit of work to get to work on Windows, but once I did, it ended up being the easiest one of all of those. So that was great once I got it working. It trained on that 8,000 training image data set very quickly. I was kind of shocked. I do have a decent GPU. I have a RTX 2070, but it's certainly not like one of the 8 GPU setups or whatever that you'd get at Facebook's AI research lab or something. But I was able to do transfer learning and train this thing in like 5 to 6 minutes and get it to this level of accuracy. It was, at least on the training set, it was getting about 93% accuracy when I stopped training early. I think, the training data set doesn't look exactly like the real world images, so you don't get quite that level of accuracy, but I just wanted to show the results here. So this first image looks pretty darn good. It kind of doesn't see the bottom of these glasses, but honestly, even a human would struggle with this if they didn't understand that glasses just naturally had this underneath. I think because of the background, it's a little hard to tell. This one was pretty good. It wasn't quite as sure about these glasses. It was only 76% sure. But the rest of them, I mean, it's doing a great job with so little training data for such a short time training. And then it does finally fail here at this angle, but I don't think it has much to do with the background. I think it has a lot more to do with the angle of the photo on this straw. Like, it just couldn't quite understand what it was, because it does detect it here. So anyway, this feels like a pretty good baseline. I'm happy with where it's at. I know that from here I can make some more progress and try to test out some motion blur stuff. And then eventually the plan is to get into doing the Blender synthetic stuff and see if that can help at all. That's it for this video. Thank you for watching. It may be a little bit until the next video. I don't know. I'm going to try not to put as much pressure on myself to put out videos as frequently as we were. We were doing once a week, but that really burned me out. And as I've gotten more responsibility at work, which is a good thing, it's meant that I've had less energy and time to do these Immersive Limit projects. So thank you for your patience with me, as it may be a little while before the next one, but we will try to update this series and keep going and sort of see it through to a satisfying conclusion. If you're not already, make sure to subscribe to the channel and like the video for, YouTube algorithm stuff, and let us know in the comments what you thought. Thanks.